Welcome guys. I address my cordial greetings to you all. This video is actually based on solutions to Mat 102 test question. The very first thing we have to consider now is question number one. Question number one, a curve has equation y equals to x cubed, plus 3x squared minus 9x plus p. Now, where p is a constant, please take note of that. P is a constant. Now, the question asks us to find the value of p for which the curve has a stationary point on the x-axis. Now, we need to get the stationary point for x. And we all believe that at SP, a stationary point, it is believed that dy over dx, the derivative of that y with respect to x is always equals to 0. Please take note of that. That's the first step. Then after that, the next thing for you to do now is to find d dx of what? Of y. That's what dy dx means. And what is my y? Y is x cubed plus 3x squared minus 9x plus p, then equal to 0. Now let's differentiate x cubed with respect to x, and that will surely give us 3x squared. If I differentiate 3x squared with respect to x, we all believe that should be 6x. If I differentiate 9x, that's minus 9. Is that clear? Then plus, if I differentiate p, that's 0. Whenever you differentiate, remember that p is a constant. So I differentiate a constant, I'll surely have 0 in that case. Now we need to solve this quadratic equation using factorization method. And the best option to use is plus 9x minus 3x. I believe you all know how to do that. And then at the same time, something is common in these two terms. 3x is common, so I'll be left with 3x plus 3. Minus 3 is common in these two terms. Now, if minus 3x divide this minus 3, I'll surely have, here in this case, I have x plus 3. Sorry for that. And here in this case, I'll also have x minus 9 divided by minus 3, that's plus 3, equals to 0. Now, you have to take 3x minus 3 equals to 0, or x plus 3 equals to 0 in this case. By the time you take minus 3 to the other side and then you divide through by the coefficient of x, we all believe that the result here will be 1, and at the same time the result here should be what? Minus 3 in this case. Now I have two results for x. I have x equals to 1 and I have x equals to minus 3, which implies that if I have this particular graph here, the stationary point on the x-axis, I have two stationary points at when x equals to 1. Let's say this is when x equals to 1 and this is 2. So at this point, I have x naught is equals to 1. This is at point 1, and I also have another point here at minus 3. So looking at this, when x equals to minus 1, on this x-axis, if x is minus 1, what is your y? You all believe that you have minus 1. Corresponding value for y is 0 in that case. That should be 0 in this case, just in the case of graph, not you putting it back into this. On the x-axis, it is seen that y is equal to 0 in that case. So now let's recall back to whatever we have here. Initially, you have y equals to x cubed plus 3x squared minus 9x plus p. Now I want to solve out for p. Let's take the first value for x. When x is 1, and you all believe that, okay, we are going to have 1 cubed, that's 1, 3 times 1 squared, that's 3, minus 9 times 1, that's 9 plus p. And then we have y equals to 4 minus 9, that's minus 5 plus p. And the corresponding value for y on that x-axis, you should believe that that's 0 in that case. So by the time you find p in this case now, p is equals to what? 5, which comes out as option D. Now, the second, you don't have just one solution to this. And at the same time, what if you try the second one? The second one, which is when x, you have two stationary points for x. When x equals to minus 3, minus 3 is power of 3, that's minus 27. 3 times minus 3 squared, that's also plus 27. Then minus 9 times minus 3, that's plus 27, then plus p. Now at y equals to 0 on that x-axis, this cancels this, you have 27 plus p. So p is equals to minus 27.